Oh my gosh, on to part 3 now of section 3.8a. Yeah, this is still A, there's a B coming too, but this part should be the last of it here. So now in this fifth part of our notes, we're going to talk about writing equations of lines in slope-intercept form. So remember the names, guys. Slope-intercept form means that we need two things. We need to know the slope of our line, and the intercept means B, the y-intercept. Once you know those two things, we're good to go. Well, enjoy it, guys. Take a look at example A. What have you been given here? The slope of -3, and the y-intercept of -1. So if an equation in slope-intercept form is of the form y equals mx plus b, you need to know the values of m and b, and sure enough, that's what was given to you in this problem. So this one's a freebie, guys. Y is equal to, our slope is -3, then an x, and then plus your y-intercept. So plus -1 means -1, and happy holidays, everybody. I don't know that you're ever going to see a problem that easy again here in the future. Most of them are going to be a little bit tougher, like example B here, where you've been given a slope of 2, but not a y-intercept. What you've been given is a random point. So I want you guys to ask yourselves very, very carefully, what do I know about this line? I was given the slope, and I was given a random point that is on this line. So what form are we going to go to here? Point-slope form. This is the useful case right here for point slope. And so everybody hates learning it, and everybody says to me, why do we have to learn a new form here? What's the point of point slope form? Well, it's really darn useful when you know a point and the slope of your line. So the general equation of point slope form is y minus y1 equals m times x minus x1. And we're going to fill in values now for m, x1, and y1 based on what was given to us in this problem. So here we go. It's going to be y minus y1, which is the y-coordinate of your point right here. That's a 1. Notice this is positive 1, but right here it looks negative. Equals, let's keep going. The m comes next, and the slope here was given to us as positive 2. And now in parentheses, it's going to be x minus, and x1 is the x-coordinate of the point that we were given. So we're subtracting a -3, which means we're actually going to add 3. So once more, this 3 is negative, but here in the equation it looks positive. So everybody, that is, I'm going to slide this down, that's actually your equation now in point slope form. But the directions, if I go back and read them again, said they wanted every equation in slope intercept form. So now, what we have to do now is follow the rules of algebra and convert this equation from point slope form into slope intercept. And how are we going to do that? Very quickly, guys, we solve for y. That's how you get something into slope intercept form. So the first thing we're going to do here to solve for y, we're going to distribute that 2. Y minus 1 is equal to 2x plus 6. And then to get y by itself, we just need to add a 1 on both sides of the equation. And that'll give us y is equal to 2x plus 7. And there's an equation now that's in slope-intercept form, so I'm tempted to box it up and move on to the next problem, but I really should think for just a second. Does this equation do the two things that we needed it to do? Does it have a slope of 2? Yes, it does, because now that I'm in slope-intercept form, I can read the slope right there is 2. Here's the real test, though. Does it contain the point -3, 1? Well, let's try some substitution here, guys. Our y value at that point is 1. That should equal 2 times an x value of -3 plus 7. So 1 equals 2 times -3 is -6. -6 plus 7 is +1. Check. 1 does equal 1, so I feel really good and confident in this answer right here. All right, so the third example, wait a minute, it's there somewhere, there it is. The third example really works exactly like the one that we just did. You've been given the slope and a point, so we should be able to do example C the exact same way you just did example B. So I'd really recommend, if you're watching this video at home, that you hit pause, you try this one on your own, and then you come back and see if you got it right. All right, so with the information we were given, we had the slope and a point. We're going to go yet again to point slope form. Let's dive into it. It's going to be y minus your y coordinate. Minus negative 7 becomes plus 7. That equals now your slope, which is negative 1/2, and then in parentheses, x minus whatever your x coordinate is, which is 8. Let me point out again, guys, this is a positive 8, but it looks negative here. This is a negative 7, but it looks positive over there. So with point-slope form, the numbers kind of lie to you and they change signs. We're going to get this in slope-intercept form now by distributing the negative 1/2. Y plus 7 is equal to, that'll be a negative 1/2 x. And how about now, guys? Negative 1/2 times negative 8. So a negative times negative is a positive. And remember, guys, that when you're doing multiplication, what's 1/2 times 8? Just think of the word of right there in the middle. What's half of 8? Answer to that is 4. So that's where we are. And now to get y by itself, we just need to subtract a 7 from both sides. And we should have our answer now of y is equal to negative 1/2 x, and a positive 4 minus 7 is going to be a negative 3. How would I test this answer? Yet again, I would take this ordered pair and plug it into this equation. Our y value here is going to be negative 7. That should equal a negative 1/2 times an x value of 8 and minus 3 at the end of all that. Let's clean it up. Negative 7 equals, okay, half of 8 is 4, so negative 1/2 of 8 is negative 4, then a minus 3, and negative 7 is equal to negative 4 minus 3 is negative 7. So check, feeling really good about this one too, so there's my answer to example C. Okay, let's move on to D, and you're going to look at this one and probably feel just a little bit dejected at first right here. You're going to say, I don't know how to do this problem yet. And I get why. This is different than the two that we just did. In those last two problems, I gave you the slope and a point, and you were able to go directly to point-slope form. So instead of just looking at a problem like this and saying, oh no, I don't know how to do it, ask yourself, what did I know in the previous problem that I don't know here? And the answer to that, I hope, is obvious. We weren't given the slope. Man, it would be cool if there was a way to find the slope of a line passing through 2 points. Oh, wait, there is. That's what we did way back in the first video here at the start of this really, really long section. We're going to use this formula right here for how to find the slope of the line that passes through 2 distinct points. So m equals, let's write it out now because it's been a minute, y2 minus y1 over x2 minus x1. What does that do for us here, guys? Y sub 2 is 7 minus y sub 1, which is negative 8, so that becomes a plus 8. All over x sub 2, which is 4, minus x sub 1, which is negative 1, that becomes a plus 1. Oh, and this isn't that bad. I see it now. That's a 15 over 5, which divides evenly to make 3. Now, if we were going to graph this line, I would make that a fraction and call it 3 over 1, but since we're writing an equation here, I like it just fine as 3. So where are we now, guys? We know the slope of your line right here is 3, and then we've got 2 points up above. So yet again, we're going to go to point-slope form because we know points and a slope. Now, the one thing that's a little tricky here, you actually have too many points. So I'm going to focus on the one I like better, which is this one. If you can avoid dealing with negatives, do that. And let me cross this out, although I'll come back to it later. So we're going to use this point and this slope to write our equation in point-slope form. Here goes. Y minus your y coordinate, which is 7, equals your slope, which is 3, and then in parentheses, x minus your x coordinate, which is 4. So there's your equation in point-slope form. Now let's solve it for y. Y minus 7 is equal to, we're going to distribute now to get 3x minus 12, and then we'll add 7 on both sides, and that should do it. We're going to get y is equal to a 3x, and minus 12 plus 7 is going to get us a minus 5. So that should be our answer. Let's check that real quick. And actually, if you really want to make sure you did this right, check the point you didn't use right here. Let's use negative 1, negative 8. So my y value is negative 8. That should equal 3 times an x value there of negative 1 minus 5. So negative 8 is going to equal, I think, negative 3 minus 5, and negative 3 minus 5 is negative 8. Yeah, so check. This is working out. That equation looks good too. E is a lot like D, guys. 2 points have been given to you, so I'd like you to pause the video right now. Try example E. Should follow the same pattern we did in part D. Let's see how you guys did. Okay, so the first thing we need to do here is find our slope. Y sub 2 is going to be 11 minus negative 4. That becomes a plus 4. X sub 2 is going to be negative 12 minus that first x value of 8. Let's see what that does for us. 11 plus 4 is 15. Negative 12 minus 8 is negative 20. We can divide a 5 out from both of these numbers and get 3/4. And even though my negative is currently in the denominator, I like it better in the numerator, so I'm going to put it right there. All right, guys, we've got ourselves a slope, and we have to choose which point to use. Each of those points is one positive and one negative. So I'm going to go with this one and not use that guy for right now. Okay, so we're going to go to, that's not what I wanted. We're going to go to point slope form first here because we know a point and we know our slope. So let me grab blue, and here we go. Y minus negative 4, that becomes a plus 4, equals your slope of negative 3/4, and then in parentheses, x minus the x coordinate here, which is 8. So let's work on solving that for y. We'll distribute the negative 3/4 first. Y plus 4 is equal to, well, that's a negative 3/4 x. Negative times negative is positive. And guys, you'll be able to use your calculator here, but here's a cool shortcut. You take this number here, 8. You divide it by this number on the bottom, and then multiply the result by this number on top. So what I'm really doing is taking 8, dividing it by 4, and then multiplying that result by 3. 8 divided by 4 is 2, times 3 is going to get us 6. And again, that's positive because it was negative 3/4 right there times negative 8. Okay, now we just need to subtract a 4 from both sides, gone, and that gets us y is equal to negative 3/4 x and then a plus 2. So there should be our answer. Let's test it real quick just to make sure we got it right. Let's use this point right here. Our y value there is 11. That equals, or should equal, negative 3/4 times an x value of negative 12 plus 2. 11 equals. All right, and let's do that trick I just taught you guys. Take the 12, divide it by 4, which is 3, and then multiply 3 by this 3 to get 9. And it should be positive because we just multiplied a negative times a negative. So that gets you a 9 plus 2, and the last I checked, kids, 9 plus 2 does equal 11. So check yet again. All right, we are hot. That number, or that equation is right also. Okay, so that's just about everything I wanted to go through with you. I just want to show you a couple of weird cases real quick, because if I didn't show you this, you guys would see this on your homework on a test, or you'd get mad at me and say, hey, you never showed us how to do that one. So this looks, at first glance, like everything we've been talking about for the last two. 2 points have been given to you. First thing we need to do is find the slope. So y2 is negative 3 minus y1, which is also negative 3. So that's a plus 3 all over a negative 2 minus 5. And right away I see something weird. Negative 3 plus 3 is 0. Negative 2 minus 5 is negative 7. 0 divided by any other number is 0. So look at what just happened, guys. Our slope is 0. Now that tells us something that we probably should know, but it really doesn't help us answer the question, even if we got the thing we were supposed to get. So what I want to remind everybody of is the fact that 0 is a real number, and you don't have to change, you don't have to deviate from what you normally did just because you got a slope of 0. We still know, whichever one you want to use, we still know a point, and we still know the slope, so I'm still going to go to point slope form. So here goes. Y minus your y coordinate of negative 3, so that's actually a y plus 3, equals your slope, which is 0, and then that's going to get multiplied by x minus your x coordinate, which is 5. And what did we do here in the last 2, 3, 4 problems, I think? We distributed the slope. Do the same thing, guys. I don't care that it's 0. Keep doing the same thing. Y plus 3 equals, and here's where things get just a little bit weird. 0 times anything is always going to equal 0. So that's a little bit different right here. If that slope is 0, you don't even need to bother writing the x anymore. The x is gone because you multiplied it by 0. 0 times anything is 0, and now we still do the same thing as before. We solve for y by subtracting a 3 on both sides. And we end up with this weird-looking equation of y equals -3. Now, what's really odd about that, guys, is the fact that this equation, unlike the last 5 problems we've done, doesn't contain an x. And there's a reason for that, and I wonder if you guys saw it or not. If you looked back at the original problem that was given to you, you might have noticed that both of these points contained the exact same, which one? Y coordinate. Here, your y value was -3, and here, your y value was also -3. And sure enough, what equation did we end up with? Y equals -3. And guys, what I'm hoping you saw right here is that if your slope is 0, that tells you then that your line is going to be horizontal. I had to think about how to spell that right there. And this, therefore, is the equation of what a horizontal line is going to look like. Y equals a constant, but there will be no x's in your equation. Now, we'll write that down in one convenient spot in just a second, but let me take you to the last example we're going to do here. Now, in the problem we just looked at, guys, the 2 coordinates there had the same y coordinate of -3, so our solution was y equals -3. What's going on here? Yeah, maybe you see it. Now, let me pretend for a second I didn't see it. Let me do this problem the same way I've done the last 6 now. M equals, here we go, y sub 2, which is 0, minus y sub 1, which is 2, all over x sub 2, -5, minus x sub 1, also -5. So that's a -5 plus 5. That gets me a -2 on top. And a 0 on the bottom. And any time you take a number divided by 0, your slope here is undefined. That means that we are dealing with a vertical line. But we're not done with this problem yet, guys. We still need to come up with the equation. Now, on the last problem, when we found that our slope was 0, I told you guys not to panic, not to freak out. Do the same thing you always do. Go to point slope form and just put your 0 in for your slope and then treat it like normal. But unfortunately, you can't do that here because you don't have a number to put in for m. Don't bother to write this down, guys, but it would look something like y minus 0 equals something times x plus 5, but there's no number you can put there because your slope is undefined. So forget about writing an equation then. If you don't have a slope, you can't do it. But what you need to do is kind of work backwards here and recognize something. This line in this problem is vertical, and the previous problem kind of gives us a hint. This line had a slope of 0, which meant it was horizontal, so its equation was y equals a constant. Horizontal lines are y equals some number. Vertical lines, therefore, are going to be x equals some number. And what do you notice about the x coordinates of both of these points here, guys? They're both -5, so x equals -5 is the equation of this vertical line. In fact, -5 is the x-coordinate of any point that's located on the vertical line that passes through both of these. So those last 2 things we did there are kind of weird, and that's why I think it's a really good idea for you guys to put this table in your notes and put a big fat star right next to it and say, hey, we need to study this table right here because this is something people goof up all the time. All right, guys, in a horizontal line, your slope is always equal to 0. And the equation of a horizontal line, which is what we dealt with right here, always looks like this. The x goes away because you're multiplying x by 0, and you just end up with, here you go, y is equal to a constant. Now, a lot of teachers and a lot of books are going to have you put a C right here because C stands for constant, and that's true, but I actually want to be a little bit more specific. Y is equal to B here, and the reason I'm using B, just like at the beginning of this section, B is the y-intercept of this line right here. Now, where can we go from there? Vertical lines have a slope there, everybody, that is undefined. Or you could say there is no slope. And the equation of a vertical line there would be x equals, but not b. That's not our y-intercept. It's actually a constant called a. And as I told you guys earlier, if b is your y-intercept, then a then is going to be your x-intercept. All right, so that table, I think, would be really, really good for you guys to have in your notes. So just about done. Last slide. Let me show you really quickly how easy this can be. Graph the line y equals 2. What I'm hoping you're going to recognize is that this equation has no x coordinate. It's only y. So we're dealing with this kind of equation, so it's a horizontal line. And the number that I've given you here, b, is the y-intercept of your horizontal line. So right here, guys, 2 is your y-intercept. So from the origin, I'm going to go up 2 units and place a dot right there. And I know that this line is horizontal because there is no x, so I draw the one and only horizontal line that passes through that point, and that is the line y equals 2. Every single point on this line has a y-coordinate of 2. That's what they all have in common. How about the second and last example here, guys? How do we graph x equals -6? Well, because this one is x equals with no y, now I'm dealing with this. That's a vertical line. And a, this number here, is our x-intercept. So this one is going to be a vertical line, and -6 is the x-intercept. So from the origin, I'm going to go 6 units left and put a dot right there and draw the one and only vertical line that passes through that point there, and that in green is the line x equals -6. So guys, graphing horizontal and vertical lines are actually much, much easier than graphing all of the diagonal lines that we talked about earlier, lines that would have a particular y-intercept and a particular slope, and maybe they would look like that. Horizontals and verticals are a lot easier, yet people do worse on those problems because they don't study and memorize the basic ideas that are presented in this table right here. So make sure you guys study that so you know what to do when you see these easy problems and you get those points. Guys, that is the end of a ridiculously long section. So dive into your homework, have your notes handy as you're going through. That's a whole chapter of Algebra 1 we just crammed into one section there. So, thanks for staying with me, guys, and good luck, everybody.